Hi, Michael here. One of the ways that scientists attempt to remove their biases when studying nature, the natural world, is by removing their emotions from their processes. We're taught this young as scientists that the thing that can most easily disrupt any scientific pursuit is putting your emotions onto your studies. Like whether it's some guy wants to prove a point, so he fudges some numbers, or somebody wants to see something, he doesn't like something, so he doesn't record it. The best way to get rid of this stuff is to get rid of your emotions according to current thinking. Well, it turns out that's wrong. There's a lot more to human bias than just emotions. And I'm not going to talk about emotions right here, but emotions are actually far more important for your intelligence than they've been given credit for. But we'll get to that another day. For now, one of the most important things scientists can do to remove their biases is to understand that we are evolved organisms. We are evolved animals. We evolved as animals on this planet. And our senses, especially our vision, which evolved very long ago, millions of years ago, is a very primitive sense, yet we use it to determine the world. And unless we get rid of our flawed evolutionary biases, we can never properly explain the universe. Let me give you an example, and this really relates to particulate physics, which says that the universe is an endless series of ever smaller objects interacting together in some way. For me, that's a hangover from evolution, where our early evolved eyes see things in the environment and say, oh, this is separate from this is totally different, there's no connection between the two. It turns out that's just the way evolution works. Just as a fish doesn't know what the composition of water is, but swims in it, lives in it, doesn't need to know it, it thrives in it, doesn't need to know what the water is. Evolution doesn't explain things, it just allows an organism to be better by sensing or manipulating the environment better than their peers. That's all it does. So let me give you an example of how this works. I'll just take out these two little cards here. Library card and a recreation card. So this is a distinct object, separate from everything else. Ugh, sorry about that. So these are two distinct objects, separate. There's no connection, right? There's nothing binds them, right? Separate. But if I do this, go like that, and all of a sudden, these two objects become one. So there's a connection between it. Or is it three objects? Is it this one card, my saliva, then the other card? What is it? Surface tension, hydrophilic bonds with the water between the loose electrons on the surface, whatever. What is it? It's something in there is now making these, what appear to be two separate objects, a single object. And that's just the way evolution works. We don't know about these little connections between all these different objects. We don't need to know that. We just need to know these are things we can pick up, move, eat, kill, set up, do whatever we want with. Evolution doesn't impart understanding. Evolution just allows an animal to be better than its peers in the environment. That's it. In the same way, with our primitive evolved vision, we also have a primitive idea of objects. So when scientists talk about removing bias, we haven't removed the bias of our primitive eyes. We have not done that. Allow me to give you some examples that'll be maybe a little bit clearer. I'm going to show you here. This is the Niels Bohr model of atomic structure. As you can see, it's a single electron in orbit around, distinct pieces of the nuclei, neutrons, protons. Now, it's a great little thing, and it's easier for one man to do calculations. If you have 8 protons, 8 neutrons, 8 electrons, you can eventually maybe do some calculations, do some modeling that one human can handle. Now, once you start going to higher levels of science, like hard science, as I did, you learn about the electron shell theory of atomic structure. So here's this, and as you can see, it's not quite the same as the Niels Bohr model. Well, turns out there's another model which we see from X-ray crystallography, which tries to look at the structure of atoms. And if you look at this, you can see what we get is what's called an electron cloud. So instead of like Niels Bohr's model of these beautiful, simple, singular electrons, what we got is like an electron going crazy all the way around, just inhabiting a whole spherical space, but not really, it's hard to pin it down where it is, what's it doing now, because it's a cloud. It's not clear and fast. There's no hard edge between these two states. There's only smooth or soft or interactions between these shells. So what's happening is that mathematicians, physicists, whatever, cosmologists are looking at the universe with this old idea of electrons and protons and everything being separate, distinct on itself, versus based on this crazy cloud thing, which is, clearly much more involved than this little simple model here. Currently, with what's so-called quantum, and I have issues with the word quantum, but I think just to quickly say it, what they're saying are like single objects going in and out. For me, is a process that's happening and occurring. So when they say they see like something spinning here and here at the same time, it's a process. It's a system, a field is what's going on. So me and the quantum guys have a bit of a difference of opinion on this story. But what's happening for them to be able to manipulate materials is that with the advances in computing and using better sensing equipment, what we can do is we can detect more data from this cloud, and now we can crunch it through computers to give us a better understanding of how we can manipulate things in the physical world. So that's what's happening there. It's not like there's this great breakthrough. It's just that our ability to sense what the electrons are doing, and our ability to compute that is getting greater. So we can then do manipulations to it as we are now. But one of the most important things here but they're still looking at it as a particulate based system. For me, it's not. It's all fields. And once we let go of the particles, once we start seeing the physical world and the sub-physical as a series of fields or processes, then we'll be able to uncover and properly explain exactly how our universe is structured. It is only one universe. There are not multiple crazy dimensions. All it is what we see here on the surface and what's inside beneath us. It's all the same. One universe, different processes. The sub-processes, the sub-physical give rise to the physical, but it doesn't mean that it's particulate based, because it's not. And all the models have shown the testing, like the further down you get, the less certainty we get, because it's the wrong, flawed model of looking at the universe. I hope this was useful. If not, let me know and I'll try again.